This question asks me to draw a mechanism for this substitution reaction. We'll need to decide what substitution we're doing, and then we can draw the mechanism. We have a secondary substrate. A secondary alkyl halide can do either SN1 or SN2, so that doesn't really help us here. But I see that we have a weak nucleophile in a polar protic solvent. A weak nucleophile is not strong enough to directly attack a carbon bearing a leaving group, and a polar protic solvent can solvate the nucleophile, making the nucleophile even weaker. So therefore, we'll be doing an SN1 reaction. The first step of the SN1 reaction is to kick out the leaving group. So the carbon-chlorine bond will break, and we'll kick out the chloride as a leaving group. That will leave behind a carbocation. This carbocation is highly stabilized by resonance, so if your instructor wants you to draw resonance contributors, we can draw resonance contributors with both benzene rings. I'm not going to do that here for time and space reasons, but we could stabilize this molecule by resonance. The next step would be the weak nucleophile, the water attacking the carbocation. That will form our key carbon-oxygen bond. Notice that I don't have any arrows showing the loss of any hydrogens, so oxygen is still attached to both hydrogens, therefore it still has a positive charge. To finish out the mechanism, we'll need to neutralize the product. We can use another molecule of water to take one of these acidic hydrogens, do an acid-base reaction, and that will form a final product of this SN1 reaction.